two neutral atoms X and Y have the same mass number, which is A, 40, but different atomic number, which is Z18 and Z20. Which statement is correct? Option A, they have the same number of electrons. Option B, they are isotopes. Option C, they have equal number of neutrons. Option D, they are isobars. So I'm going to give you some time, and please select your option, and then I'll give you the answer. After that, we'll discuss this. All right, so the correct option is option number D, this one, which is they are isobars. So basically, to answer this, you need to have a good understanding of atomic numbers, good understanding of mass number, good understanding of isotopes and isobars. Now, the correct option here is isobar. And why it is correct, we'll understand that, right? Okay, so let's understand this option first, that isobars, what are isobars? So isobars are nothing. So let me write it down also. Isobars are basically those atoms where you have same mass number, right? So the mass number is same, but they do have different atomic number. So the atomic number is different. So that is the definition of isobar. So here you can see they have the same mass number and the different atomic number that is being mentioned over here. So it clarifies things. All right, let's see why other options are not correct. Coming on to the option A, they have the same number of electrons, right? So atomic number differs. That means, number of electrons, they are also going to differ. So in this case, they are saying that they have same number of electrons, right? But that is not true because they have different atomic number. So you have Z18 and Z20. So that means they're going to have different electrons or number of electrons, right? So that means this option is also incorrect. They are isotopes. Okay, so I hope you recall that isotopes have same atomic number. So isotopes will have same atomic number. That is by definition atomic number, right? So this option is also incorrect. Option number C, they have equal numbers of neutrons. So neutron count changes because of Z and Y is constant, right? So that option is also incorrect. So that is why the correct option is this. All right, let's move to the next one. All right, coming on to the next question, which is the ratio of neutrons to proton is highest in which of the following options? You have option A, 11H, option B, 21H, option C, 31H, option D, 42He. Okay, so that is why, it's a really interesting question. It tests your knowledge that, you understand how these numbers are labeled, what are these numbers, and then based on your understanding, they, these kind of questions, they test your conceptual knowledge really well. Okay, I hope now you have selected the correct option. I'll give you the answer. The correct option in this case is option number C. Now we'll know why this particular option is correct. In option number C, what you have is 3, 1, and that is H, hydrogen. That means you have 2 neutrons and you have 1 proton in this case, right? So that becomes 2. Now let's move on to option A. What we have in this case, we have 1 and then H, and I can write it down like this. That means the ratio is 0. You don't have any neutron. You don't have neutron in this case. That is why this option is incorrect. In this case, obviously, this is H21, where you have N upon P is equals to 1. So that is also less than this. The final option, which is more confusing, which is 4He2. In this case, if you calculate the N upon P, turns out to be 1, right? Because in this case, you have 2 neutrons, 2 protons. So again, the answer is 1, and the correct option is C. So in this case, you have the highest number of N upon P, which is neutron to proton ratio. Coming to the next question, a neutral atom has mass number 39 and neutrons 20. Identify the element. So you can also get questions like that. All right, I'll give you the option. Option A, potassium, atomic number 19, calcium, atomic number 20, argon, atomic number 18, and scandium, atomic number 21. Okay, I'll give you some time, and please select the correct option. All right, so I'm going to give you the answer. The answer in this case is A, which is potassium, atomic number 19. Right. So to answer this one, we need to identify the value of Z. The value of Z that you get is A minus N. Right, number of neutrons you have to minus from the mass number. So in this case, 39 minus 20 is equal to 19. That is how you can immediately say 19 is, in this case, is K, which is potassium. And if you see in other cases, if you have 20, right, so Z 20 and A is basically 40 and N is 20. That's a mismatch basically. That's not going to match. And then in other cases also, if you see, it's not going to match. So that is why all these options, they are going to be incorrect, and this is the correct option, because this is how you're going to have the exact match with the atomic number. And for that, basically, this is what you need to remember. Z is equal to A minus N. That is the formula that you need to recall, you need to remember, and if you have any similar kind of questions. Very, very easy questions, but they become very confusing if you don't know the correct equation to use. And that is why, it's very, very important to understand and also remember these equations. Which of the following pairs in isoelectronic form, or which of the following pair is isoelectronic? Same number of electrons. All right. Option A, Na positive and Ne, Mg2 positive and Ne, F negative and Ne. Okay, the interesting part is Ne is there in all of them, so you need to know how many electrons are there in Ne. And then you have these in ionic form, right? So a little bit chemistry is also involved over here. Option D, all of the above. All right, so I hope you have selected the correct option. I'm going to give you the answer. The correct option in this case is D, all of the above, because all of them have total electron, isoelectronic, same number of electron, which is 10. Let's identify how. In case of sodium, you know that, one electron is gone. That is why this is what you have. So usually sodium will have 11 electrons, and if one electron is gone, so positive sign usually means is one electron is gone, right? And you have that means 10. The neon, it's already 10, so that matches. Okay, so this answer is also correct. Mg2 positive, so Mg2 positive 12. 2 electrons are gone because you have 2 positive, so that means 2 electrons, they are again gone, so it becomes 10 again. And then F negative, so that means F is 9 basically, one addition of electron, because whenever you have a negative sign, that means one additional electron is added, and that becomes 10. So overall, everything is equals to 10. So that means all of the above options, they are correct. If the frequency of radiation is doubled, its photon energy will, all right, option A, remain unchanged, option B, become double, option C, become half, option D, become 4 times. All right, so for this one, I hope you have selected the correct option. Take your time. You can pause the video also. Now I'm going to give you the correct option, and the correct option in this case is option B. Option B is the correct option. And why it is correct, we'll know. But first of all, you need to understand what is the relationship between frequency. What is the relationship between frequency and energy, right? So the equation that is very, very important, which is E is equals to h nu. So this is what, please everyone remember this. And if you remember this, you will be able to answer these questions very, very easily. So here you can see frequency of the radiation is double. If you increase the radiation, the frequency of the radiation 2 times, so this becomes, 2h nu, right? And which is directly proportional to E. So E is going to double because they are directly proportional, so to equate it, right? So that means energy is going to increase if you increase the frequency. So that means mu is directly proportional to E. And if you doubled it, it's going to become double. So that is why this option is correct. So it's not, so obviously all other options, they are incorrect. It's not going to become half. It's not indirectly proportional. It is not going to become unchanged, or it's not going to become 4 times, right? So because of this particular equation, you will understand what is the relationship between frequency and the energy. The next question is the product of wavelength and frequency, wavelength lambda, and frequency mu of an electromagnetic wave equals. Again, it's also the same kind of question where I'm trying to ask you a relationship between different components. So we need to understand the relationship between these parameters, right? Wavelength and frequency. Again, we have equation for that. All right. Option A, constant in all media, speed of light in vacuum, intensity of wave, amplitude. I hope you have selected the correct option. I'll give you some time. You can pause the video also. All right, now I'm going to give you the answer. Answer in this case is B, speed of light in vacuum. And for that, you need to know that relationship C is equal to lambda mu. Very, very famous equation, right? See, this is speed of light, right? So speed of light, the product. So that means when you multiply these two, what you get is this. And I'll also tell you what is the value of this. 3 multiplied by 10 to the power 8 meter per second. In this distance, in 1 second, light can travel. How fast that is? How fast that is? 3 multiplied by 10 to the power 8 meter per second. And the wonderful thing is we are being able to calculate that, right? Wonderful. Amazing. Okay, so now let's see changes. Option number A, constant in all media. No, it's changing in different media, so it varies. It's not constant. All right, intensity depend on amplitude, not lambda v. Intensity is going to depend on amplitude. Amplitude, not on lambda mu. Okay, this is also not correct. And then amplitude is unrelated to this. And amplitude is, again, it's not related to lambda mu. So these are the relationships that you have to understand to answer this. So I hope now everything is clear. The product of lambda and frequency is nothing but C, speed of light. According to classical physics, an accelerating electron must radiate energy. If so, an atom would. If you remember the concept of classical physics, where you have, in the center you have nucleus, and then electrons, they are revolving around the nucleus like this. They are revolving around the nucleus. And now, according to classical physics, it says that accelerating electron must radiate energy or radiations, right? And radiations, that is the loss of energy. And eventually, what should happen? Okay, I should give you the answers, right? Options first, and then let's see if you can select the correct option. Option A, remain stable indefinitely, right? So it should be in that particular orbit. Next is collapse as the electrons spiral inwards. C, lose neutrons. D, become ionized instantly. All right, I'll give you some time. Select the correct option. Okay, the correct option for this one is option number B, collapse as the electron spiral inwards, because if there is any loss of energy, what will happen? It's going to again become close to the nucleus slowly. What is going to happen? It's going to collapse into this one in the nucleus. It should, according to the classical physics, right? So that was one of the limitation. Also, when this particular model was provided, because many models they failed to explain this. All right, so let's see why other options are not correct. A is false because it becomes unstable, right? So it's according to this, it should become unstable. So this option is not correct. It's not going to lose electron because neutrons, because they are not related, right? They are different particles. Become ionized instantly. Ionization is not the direct outcome of radiation loss. That's not the case. That is not related with the loss of radiation. So that means the option, correct option is B. According to classical physics, that was the case. All right, if you have selected the correct one, congratulations. Let's move to the next. Which phenomena cannot be explained by wave theory, but can be explained by quantum theory. Okay, option A, diffraction. Option B, interference. Option C, black body radiation. Option D, reflection. Take your time, and then I'll give you the correct option, and then we'll discuss. Correct option in this case is option number C, black body radiations. So we have wave theory and we have quantum theory. In case of wave theory, the energy emission was more focused on continuous emission. So it was continuous emission that was explained. In the wave theory, in this case, you have discrete, or I'm just writing quanta, right? Energy, discrete energy distribution. So that was more focused and applicable in this case. Black body radiation, wave theory was not able to explain this. That was explained by our quantum theory. And let's see why other options are incorrect. So in case of option number A, fully explained by wave nature, yes. Interference is also explained by wave theory. And option D, classical wave theory is sufficient to explain the reflection one. The only missing link in this case is black body radiation. All right, if the wavelength of an electromagnetic wave is 1.5 multiplied by 10 to the power minus 10 meters, identify its region in the EM spectrum. All right, this question is from electromagnetic spectrum. Option A, infrared. Option B, ultraviolet. Option C, X-rays. Option D, gamma rays. This is remember type question, so I hope you remembered the region and its wavelength. Okay, I'm going to give you the answer. I hope you have selected the correct option. All right. The correct option in this case is C, X-rays. X-rays typically have the wavelength ranging from 10 to the power minus 10 to 10 to the power minus 12 meters. So that is the wavelength of X-rays. And that is why this is going to fall in this particular region. And if we talk about infrared, so let's discuss why this option is incorrect, because you have the range which is 10 to the minus 6 to 10 to the minus 3, okay, for infrared. And for UV light, it's 10 to the minus 8 to 10 to the minus 7 meters. And for gamma rays, it's 10 minus 12 meters. So obviously it's not going to fall in that one. That's why the correct option is X-rays, not others. So that is why you need to know the wavelength region, or particular wavelength in the electromagnetic spectrum. It's very, very important. Among the following electromagnetic waves, which has the maximum penetrating power? Option A, UV light. Option B, visible light. Option C, X-rays. Option D, gamma rays. Okay, select your option and just freeze it. Take your time. You can pause the video also. Now I'm going to give you the answer. Answer is D, which is gamma rays. Gamma rays are the ones who have the highest penetrating power. Now we'll understand why. So the penetrating power of any wave, any kind of wave is directly proportional to energy, and which is again directly proportional to frequency, right? And in that case, we have our gamma rays. We have the gamma rays, and they have the highest frequency. That is why they'll have highest penetrating power, and that is why this option is correct. Okay, all others, they have lower frequency value and then the gamma rays. That is why you also need to remember the frequency of these radiations, because question can come like this also. All right, let's move to the next one. Okay, if the frequency of a wave is 3 multiplied by 10 to the power 18 hertz, what is the wavelength in vacuum? Very good, very simple MCQ, numerical based MCQ question. And option is A, 1 meter. All right. Option B, 1 into 10 to the power minus 8 meters. Option C, 1 into 10 to the power minus 10. And then option D, 1 into 10 to the power minus 11 meters. Okay, as you can see, these are all values. And for that, you need to do some calculation. So please take your time, do some calculation. Whatever equation you think is applicable, please apply that and see if you are able to get the correct answer. This is a very, very important question. Now the answer in this, I'm going to give you the answer. I hope you have the correct option. If you don't, then please pause the video and then do the calculation. And the answer in this case, correct answer in this case is option number C, which is 1 into 10 to the power minus 10 meters. And we'll know how we actually got this answer. We need to follow this particular equation, which is lambda is equal to C upon nu. and everything is given, right? So you have to basically calculate lambda. In this case, we already know the value of c, so I'm going to just apply 3 into 10 to the power 8, right? And divided by 3 into 10 to the power 18, so which turn out to be 1 approximately. 1 into 10 to the power minus 10, isn't it, meters? And that is approximately, maybe in the region of gamma rays. Question can come also like this. And what are these rays? You have these values. What are these rays? So you need to know the value of all those frequency regions, wavelength regions, and then you need to, based on that wavelength value that you got, you have to say that, okay, it falls into this particular region of electromagnetic spectra, and probably this is the ray that we are having. Okay, so now that is too large. That is too large, right? And then you have B and C options, and obviously they are not going to be correct because we have already calculated these values. All right, this is how you simply calculate the wavelength, and then based on that you answer the question. All right, a classical remember type question. Arrange the following radiation in increasing order of their frequency. Okay, so not increasing order of their wavelength, it's frequency. So you have one microwave, you have X-rays, you have infrared, you have ultraviolet. So for that, you need to actually understand EM spectra really well. You have different options, 1, 2, 4, and 3, that is A. 3, 1, 2, 4, that is B, C, which is C option, which is 2, 4, 3, 1. D option, 4, 3, 2, 1. Interesting. That order is completely reversed. Okay, so take your time. Try to recall the electromagnetic spectra and try to select the correct option. You can pause the video. It might take some time from your side. And then I'm going to give you the answer. All right, now I'm going to give you the answer. The answer in this case is A. This is the correct. It's a remember type question. So you should be able to remember that you have this pattern for all these waves. For microwave, and then infra, and then you have ultra or UV, right? Ultraviolet. And then you have X-rays. Okay, please remember this because these are very, very easy type questions. And then I hope this is correct. Okay, please also double check this. So sometimes you get these questions and they're really, really good. They're very simple because you need to have simple questions. All that at the same time, they test your knowledge on EM spectra really well. So other options, they are incorrect sequence. They are mixing high and lows energy bands, so that all these options are not correct. This one is the correct one. All right, let's move to the next one. Conceptual question. Which one of the following statement is true for EM waves? All right. A, electric and magnetic fields, they are parallel. B, they require a medium to propagate. C, they are transverse waves. D, their speed depends upon the frequency in vacuum. Okay, it's your time to select the correct option. I'll wait. You can pause the video. Okay, I'm going to give you the answer. The answer for this one is they are transverse waves. Why? Because in this case, you have electric field and magnetic field. Both of these fields, they oscillate and when they are perpendicular to each other, right? That is why we call them transverse wave, and they're perpendicular to each other and also in the direction of propagation also. So they are transverse waves. Let's understand why others are not correct. So option number A, fields are electric and magnetic fields, they are perpendicular, not parallel. So that is incorrect. Option B, they require a medium to propagate. They can travel in vacuum. Okay, when it comes to EM wave, they can travel in vacuum. So no medium. Option C is correct. Option D, their speed depends on frequency. Speed in vacuum is constant. Okay, so that option is also incorrect. So based on everything, based on our understanding, we know that they are transverse waves when it comes to wave. So to answer this, you need to study the properties of EM waves very, very effectively. You need to remember all those points. Then only you should be able to answer these kind of MCQs. All right, let's move to the next one. Question: a monochromatic light of wavelength 500 nanometer enters a medium with the refractive index 1.5. Its frequency will. Okay, option A increases, option B decreases, option C remains same, option D becomes 0. right? Okay, we have a refractive index of a particular medium that is given, and a particular wavelength of light is entering into that. Okay, so let's select correct option from your side. Take some time. I hope you have selected the option. I'll give you the answer. The correct option in this case is remains same. That's the correct. All others they are incorrect. Because if this is correct, that means all other are incorrect. Now, why this is correct? Because frequency depend on the source, okay, not on the medium, not on the medium. The frequency of any EM wave of or a light depends upon its source, not the medium that is it's traveling into. So that is why it's going to remain same. It's not going to change, right? So it's same. Okay, so this option is correct. I should not be putting cross sign over here. Cross sign is for all others. All right. Has lowest energy photons. A, visible light. B, ultraviolet light. C, microwave. D, infrared. Okay, tell me the correct option. Select that correct option and then wait for my answer. The answer in this case is C, which is this one, microwave. They have the lowest energy photon in case of microwaves. Okay, now why this option is correct? Because you know that E is equals to h nu. So whosoever radiation in this case will have lowest nu will have the lowest energy, right? So as per this equation, this explains this. So in this, all of them, the microwaves, they have the lowest wavelength. All other, they have high wavelength, so you will have high energy. That is why these options are incorrect. So the winner in this case is option number C, microwave. Very common question, very easy to answer question. Which electromagnetic radiation is emitted by hot bodies and responsible for thermal imaging? A, infrared. B, ultraviolet. C, X-rays. D, visible light. Select your option. I'm going to give you answer directly. The answer for this one is this, infrared. I'm sure you have seen those cameras where night vision is there and you can see bodies when there is complete dark, because those bodies, they are emitting infrared radiations, right? So they are visible by using those thermal imaging systems, because they emit those kind of radiation. I'm sure you have seen movie Predator, where you can actually see energy signatures from any subject, and Predator was able to identify the prey when it was completely dark even. So this one is very, very important, infrared, to understand this. Hot bodies, they emit these kind of radiation, IR radiations, and those can be imaged by using thermal imaging system. All others in this case are not applicable, so they are incorrect. Here comes the numerical. The frequency of radiation is 6 multiplied by 10 to the power 14 hertz. What is the energy of 1 photon? I hope now you know to apply this equation. Now, what is given, you already know. You have frequency given, which is 6 into 10 to the power 14 hertz, right? And you also know the value of C. Sometimes you have to remember the value of C. I'll give you the value over here. Okay, but let's see what are the options we have. 3, 4, okay, 3 multiplied by 10 to the power minus 19, 4 multiplied by 10 to the power minus 19, 6.6 10 to the power minus 20, 2.0 10 to the power minus 18. These are our options. And the correct option, take your time, calculate it. I'll give you the answer. Correct option in this case is option number B. That is the correct one. Your answer is 4.0 into 10 to the power minus 19 joules. That's the correct option. Okay, to basically come to this particular answer, we need to know the equation, that is this. And for that one, not the value of C. I'm so sorry, this is not that equation where we apply C. This is the equation where we apply H, which is Planck's constant. And value of Planck's constant is, you need to remember that, 6.26 multiplied by 10 to the power minus 34, right? And if you solve this, so that means E is equal to 6.626 multiplied by 10 to the power 34. That is multiplied by 6, 10 to the power 14. And because of this, the value approximately will be equals to 4 into 10 to the power minus 19. Please solve this. Okay, so this is how you apply the concept. When you apply a correct concept, then answer you will get very close to the answer, and you need to see it, right. Also, you have two values very close to this one, and then that is why the options are very close. So you need to be very careful with your calculations, and then select the correct option. All right, let's move to the next one. Another one, numerical type question. Calculate the wavelength lambda of radiation having this energy. And you have different options. Option A, 6.0, 10 to the power minus 7. Option B, 4, 10 to the power minus 7. 2, 10 to the power minus 7. 1, 10 to the power minus 6. All right. Okay. Please do the calculation and see if you are able to select the correct option. In this case, the correct option I'll give you. Correct option. You can pause the video if you want to calculate. Correct option in this case is option number A, which is 6.0 and 10 to the power minus 7 meters. That is the correct option. Now in this case, what equation you have to apply? Directly give you the equation, which is lambda is equal to hc upon E. That is the equation that you need to apply. And when you do this calculation, you should be able to calculate the lambda. That is what we are calculating over here. And energy is being provided in this case. So H you already know, C you already know, energy is provided. You should be able to calculate lambda, isn't it? H again, I'll tell you 6.626, 6.626, 6.626. I hope you'll remember that. Minus 34 multiplied by 3 into 10 to the power 8 divided by E, that is given 3.3 into 10 to the power minus 19. Please calculate it. Okay, and the value turned out to be 6.02 into 10 to the power minus 7. Pardon me if it is not correct. Okay, so that is why the closest option. Many times you will find not the exact value, but the closest one. So the closest one in this case is this. That is why option A is correct, option B incorrect. CD is also CD are also incorrect. And another additional thing, if you have 600 nanometers, 600 nanometer, which lies in which region? It lies in visible red, orange region. You also need to know. So for that, you also need to know the visible spectra, right? What are the different wavelengths of different colors? You have red, green, blue. All these have different wavelengths. So the question can also come from that side also.